So here is another question on graphical analysis of one-dimensional motion. So here it is given that a ball is dropped from a height of 90 meters on a floor. At each collision with the floor, the ball loses 1/10 of its speed. We have to plot the speed time graph of its motion between the time interval from 0 seconds to 12 seconds. Okay, this. So here it involves graphical analysis, but we have to use some concepts related to motion of an object under the influence of gravity here. Okay, so first we have a ball, let's say. Okay, it is at a height of 90 meters from the ground. This is 90 meters. It is dropped from rest. Okay, it is dropped from rest. So initial velocity is equal to 0 meters per second. Gravity is acting downwards, which is the acceleration. So it will be positive. The direction of motion of the ball is also downwards. That's why. Here S, the displacement or the distance, whatever you call it, because it is one dimensional, it is the same thing, that is equal to 90 meters. So here we can use equation of motion. S is equal to ut plus half at square. So S is equal to 90 meters, u is 0, so this whole term will become 0, and we will be left with 1/2 into g t square, which is equal to 1/2 into 9.8 into t square. That implies t is equal to 2 into 90 by 9.8 root over, and that is coming around 4.3 seconds. So what it means that the ball takes 4.3 seconds to reach here at this point, striking the ground. Here at this point we have to find the final velocity. Why? Because we are plotting the speed time graph or velocity time graph, that is asked. So velocity at the end of 4.3 seconds, that we can calculate using v is equal to u plus at. Here it will be, this will be 0 and this will be simply plus gt, which is equal to 9.8 into 4.3, and that is coming around around 42 meters per second. Okay, so velocity at t equals to 4.3 seconds is equal to 42 meters per second, and this is the thing. And velocity, another thing, velocity at the start t equals to 0, which is the initial velocity, that is 0 meters per second. These are very important things, so you better highlight them. Okay, this. Now it is said that upon striking the floor, it loses 1/10 of its velocity. So when the ball okay, this is the first phase. Okay, let's call it stage 1. Okay, then is stage 2, that is the ball collided with the ground. Now it has lost 1/10 of its velocity, that is 1/10 of 42 meters per second, which is equal to 4.2 meters per second. This is the velocity lost. So the new velocity with which it will move upwards, that is equal to 42 minus 4.2 meters per second, which is the new initial velocity for this stage 2. For stage 2, the new initial velocity, that is equal to 42 minus 4.2, that is equal to 37.8 meters per second. So velocity again at 4.3 seconds, exactly where it struck the ground just before. This velocity at 4.3 seconds is just before striking the ground. This here at 4.3 seconds is just after striking the ground. Very small time gap. So almost at the same time. Okay. So this is equal to 37.8 meters per second. This is just before. Let me highlight it here. This is just before collision. This is just after collision. A very small time gap of a very small order, so we'll consider it at the same time instant. Okay, so this. Now this ball, after striking the ground with a velocity of 37.8 meters per second, which is the new initial velocity, it will move upwards up to a certain height where it will come to rest, which is the final velocity, 0 meters per second. Now we are not interested in finding the height because it is not asked in the question. We are interested in finding the time. Okay, the time, that is very important. So how much time it takes to come to rest? So that we will find out again using V is equal to U plus AT. Here acceleration due to gravity is acting downwards, so it will be negative. Direction of motion is upward. Acceleration due to gravity is downwards, so it will oppose the motion, and that will be equal to, this final velocity is 0. This is 37.8 minus GT, which is equal to 37.8 minus 9.8 T, and that is equal to, plus T is equal to how much? 37.8 by 9.8, that is equal to 3.9 seconds. Okay, 3.9 seconds. So here 3.9 seconds means we are considering stage 1 0 to 4.3. okay, here 0 to 4.3, the first collision. Then after the first collision, again we went back to 0, flip 0 to 3.9. so total time up until here, the total time up until here is 4.3 plus 3.9, that is equal to 8.2 seconds. 8.2 seconds. So here another interesting thing to remember is that here from 0 to 4.3 seconds, here it is, the velocity is v is equal to plus gt, this form, okay, this form. And from 0 to 4.3 seconds, that duration, that interval. Then from 4.3 to 8.2 seconds, that is minus gt. Why? Because it is against gravity, here minus 9.80, where the final velocity goes to 0. Okay, 4.3 to 8.2 seconds, that is minus gt. So again, another important thing to note it down here, velocity at the end of 8.2 seconds is again 0 meters per second. Okay, clear? Now, if you remember, in a video I have made entirely on motion of an object under the influence of gravity. It said that when an object is moving under the influence of gravity, the velocity with which it is projected upwards, it comes down exactly at the same point. Exactly at the same point, it will come down with the same velocity. So if I copy this portion of the diagram, okay, which will be stage 3, and I will try to make you understand. See, here the velocity with which it went upwards after the first collision, losing 1/10 of its previous velocity, it is 37.8 meter per second. So when it will come back, okay, this is stage 3. So when it will come back from this position downwards, at this point, exactly identical point, its velocity will be, final velocity will be 37.8 meters per second, okay, that much. And it will take the same amount of time to attain the velocity, that is 3.9 seconds, another 3.9 seconds, because time of ascent is equal to time of descent. This is one property. And the velocity at all the identical positions for a freely falling body sorry for a freely falling body under the influence of gravity, it is same. So the velocity just before striking the ground is 37.8 meter per second, and it takes another 3.9 seconds to achieve that. So here again, the total time here is, at this point for stage 3, is 8.2 plus 3.9, which is equal to 12.1 seconds. So at the velocity at t equals to 12.1 second, that is equal to how much? 37.8 meters per second. And here also, in this condition, when it is moving downwards, the equation is u plus at. Initial velocity is 0, because here final velocity is 0 in stage 2, that becomes the new initial velocity, and acceleration due to gravity is acting downwards, so it will be gt, that is from 8.2 seconds to 12.1 seconds, that is gt. This, and this is also important. 12.1 seconds, the velocity is 37.8 meters per second. So we have got the velocities up until 12 seconds. 12.1 second was asked from 0 to 12 seconds, 12.1 second. Okay. Now we have to plot the graph. Okay. So this will be, I think, enough. Okay. Okay, this one. Let's make the arrowheads. Okay. This is the velocity in meters per second. This is the time in seconds. So up to 12 seconds. Okay. So we'll take 1 second interval, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's extend it a bit. Okay, 9, 10, 11, and this here at 12, 12.1. Okay, little bit further. This is 0, and here it is, the velocity will take 5, 10, 15, 20, 25, 30, 35, 40, and this here will be 42. Okay, so velocity at t equals to 0, that is equal to 0 meters per second. So t equals to 0, it is 0 meters per second. This point, let's call it O, the start. Then the next is at 4.3, somewhere around here, 4.3 seconds. Let's say somewhere around here. So let's draw a straight line, a thin line. Okay, we'll draw a thin line. Okay, here at 4.3 seconds it is 40, how much it is, we calculated 42 meters per second. Let's say it is somewhere around here, this point, this one. Okay, this point. So we will draw a curve joining this with this point. Okay, let's use a thick, this one will be enough. Okay, this, and let this point be A. This is at t equals to 4.3 seconds. Okay, 4.3 seconds. Again, this is just before collision. Just after collision, it loses 1/10 of its velocity, and the new velocity just after collision is here. somewhere around here, 37.8, let's say. So it loses that much velocity. Okay, this, let's call it point B, this. Then next is, and yes, this is, here is the downward motion, downward motion with slope, you know, the GT, okay, 9.8 T. Then this is at 4.3. Then next is at 8.2 seconds, 8.2 seconds, 4.3 to 8.2 seconds, it is minus GT, and at 8.2 seconds it is 0 meters per second. So somewhere around here, 8.2 seconds, it is 0, and this is the thing here, this. Okay, again this is here, it is the upward motion against gravity, that's why the velocity reduces. Upward motion with minus GT, okay, minus GT. Then next is at 8.2 to 12.1 second, again it is accelerated, and at 12.1 second it attains the same velocity, time of ascent, time of descent, identical velocity at identical points. Again it is 37.8 second at how much, 12.1 second. So it is somewhere around here, let's extend it a bit. Okay, this, then we have here 12.1 second. Here it is, if we draw a thin line upwards, this is 37.8. 37.8, this one. Okay, and it will be here to here. Okay, this is again downward motion with plus GT. This is B, this is, let's say, point C, this is point D. This is the velocity time graph of this situation, okay, of this situation which is mentioned in the question. From 0 seconds to 12 seconds, it is 12.1 second. Okay, this is the thing. So a very good question related to graphical analysis of one-dimensional motion. In this case, an object moving under the influence of gravity.